Okay, so the point about computer science, and I know I drank the Kool-Aid about computer science and computing and data science, but I think it's good Kool-Aid. I think it's accurate Kool-Aid. So my feeling, my put to y'all is the demand for computer science is acute. It's huge. It's growing in every way. The responsiveness of the K through 12 in the U.S. is abysmal. The responsiveness of the colleges is pretty good. So we have information that absolutely should be mandated for kids to learn, and they're not learning it in high school, not in any way. So they're learning stuff that they learned in 1995, 1963. So I want to challenge you to find out what you can do with your degree, and don't get a degree because you want a degree. Get a degree because you want to do something. So here's my plug. I'm a mechanical engineer. I'm not a computer scientist, but I've done a lot of computing. So here's why I like computing. I worked with my friend to make a better heart valve. So he was doing the heart valve, I was doing the thermodynamics. I wrote code to find some boundary layer problems, fixed his heart valve. So that was a plus. We did analysis on a bridge to be able to figure out how to enhance the structure without a lot of weight. So that was computing. I had a problem with my plane. I was a program engineer on aircraft. Believe it or not, the tails kept falling off. So we were in the Navy. We take a beating on the planes. The tails kept falling off. So we did some aerostructures analysis, probably the most advanced work I've ever done. And now our planes don't fall. Now our tails don't fall off the planes. So I think you can do computing for what you want to do computing for. So what can you do with computer science? What are you limited by? You can do anything in computer science. Here's what I want you to take away. So I want you to focus on your education and encourage behaviors to finish your degree. And I want to talk about a couple things that I think we can do better together to give us a better chance of finishing, and then also it's a lot of fun. And then also to share information in these areas right here. So these are some areas about IT. I mean, we could talk about every bullet there. We can talk about for 2 hours. So one of the things that computers do really well, it's kind of an amazing thing to see people come together after a disaster. What was recently done was at Seton Medical Center, they have a bunch of developers, and those guys do a lot of development for IT. What they did is they cobbled together a website that paired two things: a need and a resource. The need was people were drowning and they needed evacuation. The resource was people showed up with a boat, but they didn't know where the people to save were. So they had and by the way, when you have a disaster like they were having, EMS is not very useful. Because imagine if you have 25,000 people making phone calls every hour. You can't do the old 911, it doesn't work. So what you do is you set up a distributed radio net, and on that radio net, they had like 35 dispatchers that were typing in, here's a family here that needs a boat, it's 6 family members, they can get in any boat, or this person is disabled, they can do this. So they I don't know, you have to talk to them and see how many people they save, but they probably save thousands of people by bringing the resources of the boats together. And the government can't do that fast. They can't move that fast unless the Marine Corps comes and lands on your disaster. So some other things here are, we have a disadvantaged population. In some cases we have a fragile population, and there's a need to try to teach them how to use computers so they can survive and they can thrive in today's environment. Sama School is a national organization, and their job is to do 2 things. One is to teach the most fragile of us how to use computers. There's no programming there, it's just basic computer use. And then they also teach people around the world how they can support themselves by using things like Mechanical Turk, things like, it's called, what the heck is it, like Odesk. It's Odesk, where you go online and you get a job. It's that's not a huge amount of money, but when you're in some parts of the world where the per capita income is $450, they can support themselves. So one thing, let me click on a couple of these things. So I think this is cool here. I think this is, hopefully, that's not it. That's not the one I want to see. Hang on a second. That's just an attack. You can look at that. This is the cool one, I think. Okay, so this is Greg's cable map. So, and this is, this is not the information I'd ever want to see in the white world. when I lived in California, a friend of mine took me down to not San Luis Obispo, Pismo Beach, and there were 3 large cable fibers that went to the Pacific from that one location. You could walk right up to it. Well, that's okay, but you can also break it if you wanted to. So at the very same time that there's amazing capability here, there's also fragility here. But I wanted to show you this because there's a story here, and these are really the transatlantic cables. This is probably 3 or 4 years old, but this gives you an idea of what follows high-speed fiber. If you have high-speed fiber, what follows that?
Business, income, money.
Money. So money follows that. Opportunity, education, the ability to build a new city. So if you look in some areas of the world, those areas will always be disenfranchised until they get high-speed fiber. Right in this area right here is one of the most disadvantaged areas of the world. It's also the densest area in the world. So if anybody needs high-speed fiber, they need it there. But in this field right here, you can do layer 1, layer 2 networking. You know, you're putting in systems, you're putting in routing infrastructure, switching infrastructure. You can do that. You can also be a sysadmin where you're putting the operating systems in on top of that. You can also be a programmer that puts the intelligence in on top of that. And then you can also be a customer facing. When you hear about a lot of people that are doing computing, realize an enormous amount of them are assist the customer. So their job is to do UX, UI with the customer. But you can work, I want you to realize that's all computing, that whole stack right there. Some of you are in networking. In the OSI model, that's OSI, layers 1 up through layer 7. And what layer are we? We're layer 8, right? Humans are layer 8. So, and that may be a good thing or not. So computer science and IT, it's not just programming, it's not just web page, it's not just networking, it's not just security, it's all of that. This is a lady that we met in some work we did before. This lady is an absolute stud, and when we met her, she was working for Google. She's working for the U.S. Digital Service now. Have you ever heard of that before? Me neither. I asked my friend of mine, I said, hey, where's Raquel? Is she up at Google still? And he goes, no, she's working for the U.S. Digital Service. And I thought he was kidding me. I thought he made it up. Yeah, right, the U.S. Digital Service. Yeah, sure. But it's a thing. Remember when Obamacare came out? And remember it broke? It was terrible. It was like the worst product ever.
Yeah, that was here in Belton. You know that, right?
Well, that was a part of it. Yeah, CGI was part of it. So I don't want to get into name calling here, especially since we're being recorded. But it didn't work when they first deployed it, and it didn't work in a big way. And there were billions of dollars that were kind of sitting here. So they brought in a group of people. They pretty much said 911 and got all the big guns out of Google and said, fix this. They fixed it. They did a good job. I don't know if you ever had a chance to interact with the site. They did a good job. That was the beginning of the U.S. Digital Service. So if you want to work in the digital services, let's make government better through better IT, better support services. And they have a pretty good rep right now. I think there's only 200 or 3 of them. They had a pretty good rep. But here's some things I want to show you that Raquel did. So notice she worked in areas of human rights abuse. She worked in areas of emergency medical care in low infrastructure communities. That's where you need to do a lot of medical care. A lot of people need it, and they don't have any infrastructure. So what can you do? So they did things like they designed an app for an iPhone that worked almost as good as a $25,000 machine that they otherwise had to airlift in. That was kind of a pain in the neck. So you can kind of see your theme here: healthcare messaging for low income, real-time temperature monitoring for cold chain supply. That's because she was in an ag area. So she also worked a lot in geointelligence. We're making Google Street Maps, kind of a big deal, license plate detection. So the deal is, here's somebody, this is an average developer. I mean, she was a good developer. I think she went to MIT, but she can do anything that she wants to do because she's worked so hard for so long. And that can be you. You can do that. And if you talk to her at any given time and ask her, Raquel, if you want to see what she does, just go Raquel Romano, watch a YouTube video. She's amazing. She's gentle, she's nice, she's a great mom, but she's a freaking stud in terms of computer science. So, that can be you, and I want to encourage you to do that. I think, we have some intractable problems that are facing our civilization right now. We also have some difficult problems that are facing our nation. everything that we need to solve any problem that we have is defined. What we need to be able to do is come up with the technological and the societal solution to bring everything together. And that's kind of a neat challenge there. So if you think of things, some of the challenges that we have, you know, how might we manage them? I mean, what are some of the challenges? Certainly we have things like, we have demographic mobility in terms of our DACA population here. We have like 800,000 people that have graduated from high school, and many of them are graduating from college. That's a good population. Maybe we want to keep them here. Overseas, they have all the people that are immigrating from, or have immigrated from Syria. How do you manage that? Well, you can do a lot to support that using computer science and IT. And they have organizations over there. You know, they have Random Hacks of Kindness, Geeks Without Borders. They have all sorts of things. Okay, so just some facts here. So it's always been like this. This has been my shtick here for 10 years. A couple of things. It's the fastest growing occupational group. There's two areas you want to get into if you want a job. One's computing and one's health. You know, and there's those vertical infrastructures have a lot of jobs. So we're not converging on being able to satisfy those jobs. So at the very same rate that the demand is going up, our ability to satisfy the demand is not going up as fast as the demand is going. Now, I'm not saying that applies right here in Killeen, but you have to identify which area of the United States you might want to move to. So you've heard probably that Silicon Valley is a hot area for development, and it is, and there's a culture in Silicon Valley that's a good place to go and get dipped in there. And what Silicon Valley teaches you is absolute intolerance for people who don't want to get on board. They teaches you an acceptance, a rigor for analysis, an acceptance for getting stuff done. They don't tolerate moving at a slow rate, and because for a lot of good reasons. So being able to export that, they've exported it to Austin now, Dallas. Dallas is building even hotter than Silicon Valley. Charlotte, North Carolina, Raleigh, Durham, North Carolina, Minneapolis. Brooklyn is huge, and Boston's always been big, Denver's always been big. So those areas are hugely hot too. So some other numbers. The reason I wanted to put this up is, you know, and I know I get all bent out of shape on this. You guys have heard STEM, 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 STEM forever, but you don't hear the other part of it, which STEM, when someone says STEM is computer science. So look at the numbers here. So this pie right here represents, this is the STEM growth through 2022. So this is the growth through 2022. What percentage of the growth is computer science?
7 out of 10.
Can you see how big that is? So let me give you an example. How many jobs will there be next year? How many new jobs will there be next year for mathematicians? 4,000. How many new jobs will there be next year for computer science? 1 million. So, but we don't have, that hasn't registered in our rising population yet. It's kind of like, yeah, I want to be a mathematician, but guess what the chances of that are happening? About 0. But if I want to use computer science to do math, which is what a lot of people do, there's a lot of other areas to work. And in the area of computer science, this is probably where you want to see your home. So my question to you is, I sort of want to force you and say, what do you want to do? Because once you start going to college and you start paying money, you need to be very close to saying, this is what I want to do. So we have support, and all these are growing. So system analysis, security, this is actually exploding. So this is a little bit bigger now. Software development, database, network admin, and support specialist. So all these are growing. All the trends are very positive. The only place where jobs are shrinking is in actual programming, simple programming. But if you're a software developer where you work with design, then you can see the growth that we see right there. One of the things I'd ask you to do is the Occupational Outlook. If you click on that, please share this with your buddies and your friends. And so this is where I get all the information. So you paid for this. You paid for this organization. This is Bureau of Labor Statistics. Every 2 years they update this. Here's why you would want to do this. Let's say you want to become a computer network architect. So let's look at that. So if you have a model for how to understand what the information is on each one of these jobs, it sort of helps you slot what's going on. So I'm picking computer architect. So here's some things that you want to look at. So pay, Yeah, you definitely want to look at the pay. The pay is good. What is your likely entry-level education? This doesn't mean this is always it. The number of jobs, and then you want to pay attention to this right here. This is the gold. This is the gold money right here. So you'll see this. The job outlook will be. It'll grow. It won't grow. So there's 5 bands. Trending normally. One of them is faster than average. One's much faster than average. One of them's less than average, and one of them's or worse than average. One of them's much worse than average. What you want to do is get yourself on the one that's much faster than average or faster than average. Then you don't even need to do anything. Just be good and they'll hire you because there are more jobs. Okay, so this is the, so 2 things. The most important thing is if you put 100 people in a room that are going to major in a STEM major like computer science or biology or math, the chances of them finishing at a 2-year degree are about 36%. So think, started off with 100, 36 people graduated. And almost nobody will finish it in 2 years. So not very many people do a 2-year degree in 2 years. And we want to speak more to that in a second. If they want to transfer and get a 4-year degree, which takes 6 years, we're talking about 11% now. So 100 started, 36 finished, they transferred, 11% finished there. Pretty dismal results, right? So it's, and what you want to decide is that's not going to affect you. You don't want that to affect you, and you can certainly keep those bad stats away from you. So here's the first one. The first step is get your educational plan. Does everybody here have an educational plan? So you want to have an educational plan, and every semester you take it. If I were you, I would take it to Miss Ozier or me or Tracy, and I would say, is this the right step for me? But the most important point is get your degree plan on this, and get a plan to finish your degree. And we'll talk a little about certifications in a second. The cool thing about being in this field is you can do a lot with a 2-year degree, a lot. So almost any area. I mean, if you're a software developer, you get your 2-year degree, and then you just grind and you go and teach yourself a lot of stuff. You go to hackathons, and eventually you'll be able to migrate out. For network security, network admin, that's kind of the hiring point for a lot of cases. So I recommend your path be this: 2-year degree, finish your 2-year degree, get a job, work part-time while you're finishing your 4-year degree, graduate with your not your 4-year degree, it's your bachelor's degree, and then just keep on your lifetime learning, because you just got to be learning forever. So that's the plan right here. Make classes your priority. So don't do this. How many hours should you take a semester? What's the answer to that? Matt, you had your hand up.
12. As many as you can manage.
Okay, 12.
As many as you can manage effectively and learn.
Okay, so as many as you can manage. John, what do you say?
15.
15.
That's about that range.
What do you guys say? So how many units should it take for a 2-year degree?
What's 60?
60. So if you want to get 60 units done in 2 years, how many do you need to take a semester?
15.
15. So one of the things I want you to know is the units you take for a 2-year degree are more than what you normally hear for federal financial aid, right? What's federal financial aid? 12 units. So they're trying to get that changed, and some states have changed that. So I would like to encourage you to take 15 or 16 if you can go full time. Some people have other demands, and that's fine.
I did 24.
And I want to discourage you from doing that. So
it was a rough semester.
yeah, so I don't want you to do something like that. And the reason is if you start to measure what was retained about 3 months after, and I've had a brutal semester like that, there isn't very much retained. And it's kind of like life sucks for the whole semester, because you're just kind of bouncing from one thing to another, but you're not really having the opportunity to do deep reflective learning, and that's where the real learning happens. Okay, so focus on your studies, get your plan out, and then I want you to do this. Now, there's some things, almost everything I put up here, somebody told me about. I'm not very creative. I didn't come up with it. But this right here is the most important point. And this is the guy that told us this was one of the guys that developed the Google search engine. His name's Peter Norvig. The guy's amazing. He's humble. He always shows up in a Hawaiian shirt and shorts, but he's really smart. You guys, maybe you've heard of Udacity. Udacity was started by Sebastian Thrun. Sebastian Thrun's the little buddy of Peter. But we went and had a conversation with him, and we said, Peter, how do we get hired at Google? And he said, well, I'll tell you what doesn't matter. We don't care about your GPA. He said, we don't even care about your degree. I'm like, Peter, man, I got students with me. Don't say that. Don't say that, Peter. Just don't. I hope he doesn't see this. But then this is gold right here. And then he said something that was just magic. And periodically, Raquel has said magic. He said magic. He said, what have you done, achieved, or worked on? And what he actually said is, when was the last time you stayed up past midnight trying to get something to work? and they didn't make you do it. And he said, if the answer is nothing, then he says you're in the wrong field. He said, we don't want to talk to you. We're not having an interview. So one of the things I want you to reflect about that, because this field is a great field. It's a challenge. I mean, you're going to be learning all the time, but it's fun. It's challenging. You know, you learn things that other people will never learn. But you got to find something that's awesome. Like, I mean, Matt and I have had a lot of classes together. So sometimes I just like sitting and poking at an operating system and finding holes, and just running little tests, with all the different tools that we have, fuzzing, writing escape attacks. I want to get in that operating system, and it may be an operating system for a car or a TV or a house. I want to get in that operating system because then I win and you lose. And I think that's fun. It's like a massive puzzle. And what I ever do is always very legal. I never do anything that's illegal. So that's the security part of the house. On the other side, from the protect side of the house, then I think, what's our strategy to be able to make our security and our computer environment so secure? What's that strategy? Because those work against each other. But my mom's up in Texas. I want her to stop getting hacked. So what can I do to her to make sure everything's rock solid? So I get excited about that. My question to you is, what do you get excited about? And then when was the last time you stayed up? You know, when you want to find a project or something that so invests you that you don't even want to go to class. You go, honey, I'll be there later. I don't want to eat right now. You know, don't say don't bother me, but just say, can I have some more time to work on this project? That's what I consider to be above and beyond work. So the point is, when you graduate, you won't get an interview because of your degree. You won't get an interview because of your GPA. But you'll get an interview. As a matter of fact, you will probably get the interview as a consequence of all the other things that you did. So I would like you to consider that that's the way that you roll. So think about activities that you do. Now, some of you are in my group. I've been spamming you as much as I can. You're in the CTC computing group. You'll see all sorts of stuff. And if you don't like the spam, you can delete yourself from the group. But my emphasis is cybersecurity and software development for the group. A couple of things about college. You know what? This is an approach for how you should engage class. And I think it takes some time to get through it. It kind of goes like this. When you sit down in a class, you have to have a strategy for understanding and learning what's in that class. It can't just be butt in seat and think that I learned about 3 hours worth of stuff because my butt was in the seat for 3 hours. That doesn't work. Also, three weeks after you sat in that class, you'll remember nothing. So I want you to have a strategy about how you remember things. And there's other conversations that we can have. But passive learning means no learning. So what I would ask you to do is, when you're in any class, you should be able to take notes for that class. And I'm not talking about the book. I don't care if it's in the book. I don't care if it's online. If you don't have notes, you don't know it. So you want to write down notes. And by the end of the course, you can get any course at any college down into about five pages of notes front and back, unless it's like thermodynamics or something. I mean, because what you're going to do is constantly revise it, because you understand that. Like if you haven't taken networking and I tell you OSI model, you're probably going, ah! And then your first page is you write the OSI model and you write all seven layers, and you're just so precise. But after you learn it over and over and over again, you don't have to write everything down there. You just kind of put a one line, OSI model, got it. You know, so in that process of writing and rewriting, that's the way that you're gonna remember this stuff. It's the only way that humans remember. So please consider it. Whatever your strategy is now, revisit it in your mind and see if it works for you. If you do this right, then when you prepare for a certification exam, it's just a simple freshen up and step into the exam. If you're doing it wrong, then when you take a class, you're not ready at all for a certification exam. And I think for your class, a lot of your classes here, if you take Network Plus, you should be ready for a Network Plus exam. Security Plus exam. You should be ready to take it. Get some people, study together. I'll give you some recommendations if you want. So this is a culture for success. This is what we've used for many of our interns. So when we inject them with the intern virus, this is what we talk to them about. You wouldn't know that people are paying for their own education by their inspiration in class. They just kind of sit down, they take out their phone and they look at their phone for the whole class. Then when the class is over, they put the phone in the pocket and they walk away. And they pay for that. So who should be the most enthusiastic learner in your family? You should be walking and talking. I'm trying to get Maria to stop people at HEB. So you should stop people at HEB. It's okay if you fail. It's okay if you try something that doesn't work. If you're not trying it and if you're not breaking stuff, you're not trying. So don't be so prissy and just try to get it just to work like this. Just kind of hook stuff together, get in there, wade in there, and screw it up, then figure out how it works. It all comes down to work. So here's something that I only hear in the U.S. Maybe you've heard it with me. You know, you can kind of walk with me on this. Have you ever heard anybody that you know say, "I'm not just a math person. I'm not a math person. I'm just not a math person. It just never came to me. I'm just not a math person." You know the only place in the world that you're allowed to say that? Here in the U.S. If you say that in Russia, get yourself back in there and study this math. Well, that's sorry about that accent. But you don't get to say that in any other country. It's like, get in there and study it until you understand it. And part of it, and yeah, of course there's some people that don't understand math, but it really comes down to a matter of work. It's kind of like, did you spend 25 hours last week studying math? If you didn't, then you don't know if you don't know math. Now, this isn't math, but it's programming, it's design, it's networking, it's troubleshooting, it's attack, it's defend. So it is all 99% perspiration. It is all how hard you're willing to work. It's nothing. I don't give me somebody who isn't an A+ student. Don't want them. But I'll always run rings around them if you give me a student who's willing to work hard, because there's no end to that. So your primary responsibility is for success. It's you. You need to own it. I'm a big fan. You kind of get the idea. 100%, and then give more. If you have a workshop, you get there early. You find about that person. You shake them. You turn them upside down. Shake their brains out. Pick their brains up. Put them in your pocket, and you learn as much as you can from that person. Don't be. What I would like you to do is, the next time you're in a class, watch how people work. We used to work with a program called the ACE program, and we would put people through this. It was like a week, and they had to do it. When they were done with the program, you could tell those students by the way they acted on campus, about the way they took responsibility for their learning. I want you to think about how you would do that. And I think this is important. What if you're not a good communicator?
Work at it.
Okay, so work at it. Can you be in this world now and not be a good communicator? Isn't that like having a supercomputer without a keyboard or a monitor? It's like, Matt's really picking on Matt. Matt's really smart. He's shy, doesn't want to talk to anybody, but he's really smart. Now we don't get to see all the advantage of Matt or all the cool stuff that he knows. So yes, you need to be a good communicator. That's like, you don't get to not be a good communicator in the world these days. I can't imagine what maybe if you're an artist and you're in a room somewhere painting. So some things here, and I don't want you to go crazy, but if this is what you want to do for your vocation, then really sink your teeth into it. So these are some best practices here, and we kind of talked about that curriculum advising. Colleges in the U.S. and universities in the U.S. have changed a lot in the last 4 or 5 years, and the goal now is to not just attract students, but to get students to graduate. So this area about curricular advising, it's a lot more mature than it used to be. We have a system here that's kind of a rocky system, but I want you to Band-Aid that so you know, like, here's what I want to see from you. When this class is over, or when our workshop is over, then you put a date on your calendar, and that date says, I want to see Tracy about my major. You put it on your calendar, because if you go, oh yeah, I'll think great thoughts, and then the great thoughts will leak away. And now you have a date in November by which you'll show up at her office and say, can we talk for an hour? Can I buy you a burrito? So let's talk about this. Then you ask her, what are some other things? Ask her this, what are some other things that I should know? What are the other things I should do? Remember, this is just the center of this is just the nucleus. All the other things you do outside of class are bigger than class, and they're more valuable than class. Internships. There's internships that are unpaid internships. And those internships, you need to use additional effort to curate, so you don't end up in an internship job where you're just not getting it done. And that's I'm going through that right now with a student to make sure she gets a good internship. So we have unpaid internships, and unpaid internships are a part of most of our degree programs here. So what you should do from the day you take your first class is you should start thinking about what's your unpaid internship going to be. And I'll give you some ideas about where you can look. Then there's also paid internships. the difference between an unpaid internship and a paid internship in terms of how much you're gonna learn, they can almost be a tie. I think they can be a tie if you do it right. But would you rather make money or not make money? Trick question. Everybody would rather make money, right? So we're getting into the internship season right now. So the internship season starts about the end of October. You should be shaking the trees as hard as you can. What I recommend that you do for either an unpaid internship or a paid internship, starting from the middle of October till the middle of February, you should apply for 3 internships a week. So I mean, I have students that applied for 80 internships, and then they don't say that's a lot. They say that's what it takes. So there's a process for getting hired. You know, you talked about a coding interview. It depends on what you want to do. And also, if you apply for an internship, then you're going to start thinking about the things that you otherwise will wait until you get a job. And you don't want to wait until you get a job to see if you're prepared for the job. So those questions, you need to force those questions early by doing an internship. So I don't know, some people heard, but there are different internship programs, like some that we use a lot. We use the NASA internship a lot for some of our STEM majors. We use Lawrence Livermore National Labs and the labs at Alamogordo for our network security, network admin majors. It depends on where you are in your program. After you have A+, Net+, Security+, and you got to have a Microsoft install, configure, and manage experience or course or something like that. You just gotta.
MTA or MCSA?
It doesn't matter. They won't ask you for your certification. They'll ask you for, do you have the knowledge to do it? And here's the other thing that I didn't find about internships. You know what you have to do? You know what you have to know for internships? Nothing. You know, what do you need for an internship to be successful?
Willing to learn.
You need to be willing to learn. You need to work your ass off. So that's one of the things that you want to be able to do. Because me and my team, so there's like 5 people I used to work with, that we would have about 120 interns go out in the summer, every summer for internships. And we closed off a lot of internships because we thought that our students weren't ready, but our graduates weren't ready either. So we just went ahead and started pushing them, and they accepted them. So I want you to start looking for internships right now. So tonight or tomorrow, I want you to start looking for internships. And remember the 2 categories. The unpaid internships, those are probably going to be fairly local because we don't have a huge tech infrastructure here in Killeen. But there are internships that you can find. Then there's the paid internships. The paid internships are generally going to tend towards software development. So paid internships, there's a lot of, the landscape now is way better than the landscape used to be. So, 5 or 6 or 8 years ago, there weren't really very many paid internships for college students at the community college level. But one thing I definitely would say to everybody is, you guys should apply for an REU. That is the best internship program. So today, part of it is you make your own destiny. Today, I want you to go home and study about what an REU is, because you're going to start seeing the applications hit the street. And REU stands for Research Experience for Undergraduates. What they are, the National Science Foundation gives money to different organizations to bring in people from community colleges and universities that don't do research. That's why it's called Research Experience for Undergraduates. So if you go to University of Texas, they're gonna do the REU. They won't send students to the REU because at UT they do research. They don't need to do REU at UT. So if you sign up for REU, so right now, next summer we have 2 slots out at the Advanced Supercomputer Center down in Texas. We have 2 internship slots for this campus. So somebody's going, and it's a paid internship. You live on campus, you get $5,000, and I think they give you a bus pass. But it's pretty cool. So this is not the only one, but you just want to be vigorous about. IBM has got a lot of internships here in this area. If you know how to work with your hands, and you know some digital electronics, and you know some software development, SpaceX is up in McGregor. They're pretty good about interns. I went and talked to the guys at CGI a couple times. I didn't get a good feedback. They want somebody to know like 28 years of Java when they graduate from college. So I don't know how that's going to work. But the important thing is, internships feed into the strategy about how you get a job. from two ways. If you've done an internship, you know how to apply for a job. There's so many people that graduate from college that don't know how to get a job. If you find yourself mailing in applications, you're doing it wrong. If you find yourself going online and submitting all your stuff into a box, you're doing it wrong. Referrals are the key to getting a job. Otherwise, you can find yourself sending 400 or 500 applications. And I gotta tell you, it doesn't matter. So there's a strategy for doing that. But this is huge right here. Internships have become the coin of the realm in getting a job. So it's not very likely that somebody's gonna hire you unless they have some sort of proof that you're a good worker. You guys are all awesome, you gotta do this. So this is a big deal. So some things that we've introduced is make sure you're on the right ed plan, right? Make sure you find something that is so cool you can't sleep at night. I mean, I would recommend that you start with, Matt knows how to install virtual machines. Have you guys installed virtual machines?
I have plenty.
Yeah, so what I want y'all to do is, or whoever's done it, get a laptop, install, I mean, you could use VirtualBox or VMware Workstation, but get VirtualBox, get Kali, get a compliant target, and just start attacking it, start finding out stuff. Because you'll find out, hey, this networking stuff's cool, because now I know how to get in there. If you know coding, now you can start writing your own attack scripts, and that's pretty cool too. So those are some things you can do that you don't even need any cool stuff. You can Matt knows how to show you, Ken knows how to show you. We were relatively successful with Ubuntu. That end.